I'm back. So one phase change I didn't talk about, and it's one that may not be entirely familiar for you, is that a solid can go directly to a gas and skip the liquid state. If you've ever put ice cubes, tried to make ice cubes in your freezer. So of course you take a tray, you put liquid water in it, and if you wait too long, like you come back a couple weeks later and you look at your tray, your ice cubes may have kind of look like they're shriveled up. They look like they've gone, that water has gone somewhere. And what's happened is that water froze, but then it actually went from straight from a solid to a gas. We call that sublimation. Let's see if this video works for us.
In the flask is solid iodine. In the test tube is ice. When we heat the iodine, its weak induced dipole forces are overcome, and the iodine sublimes into the gas phase. The gas recondenses as a crystalline solid on the cold test tube.
Is that not cool or what? So actually this thing right here, let me see if I can draw on this. This thing right here is just what we call kind of a cold finger. So there was ice in there. So down here there was a little bit of some sort of heating element. So when it talked about the induced dipole, that's just the webbing between the I2 molecules. It went from a solid to a gas, and then here on this cold finger it redeposited into a solid again. So that's kind of what the video is all about. Let's see. It'll let me go back. Oh. Very well. Okay, so we call that sublimation. So, and like I said, the or like we saw a minute ago with the I2, that purple stuff, actually it can go straight from a gas to a solid like it did on that cold finger, and we usually call that, usually call it deposition, where it deposits it. It skips the, excuse me, goodness gracious, it skips the liquid state. It goes straight from a gas to a solid. Another example, there we go, my build's caught up. Over here, another very common example is frost. Okay, so for instance, let's say it's like, I don't know, going to get down into the upper 20s. When you go to bed, the grass is fine. There's nothing on the grass. But when you get up in the morning, there's like these ice crystals on the grass. And so what's happened is that water vapor has come out of the atmosphere from a gas, and it's gone straight from a gas to a solid to form frost. There you go. Let's see. Escape. Discard. Or are you serious? We're almost done with this. My goodness gracious. So this kind of summarizes all of the terms kind of we talked about a minute ago. Boy, I am just not having a good day of it. Here we have our kind of left to right endothermic things that we have to put heat in order for like a solid to go to liquid. We call that melting. In order for a liquid to go to gas, we call that evaporation. Okay, these are endothermic physical phase changes. We're breaking bonds, but not chemical bonds. We're breaking that webbing, those intermolecular bonds. And then these are, so that's endothermic processes. These are exothermic. So when this is occurring, when freezing is occurring, or condensation like in a cloud is occurring, or I usually call that deposition, that last one, when those bonds are being formed, energy is released. Deposition. So bonds are being formed, energy is released. But my emphasis here is that those are all examples of physical changes. So just to kind of remind you, feel free to take this and put it with a rap or a tune or something, but it takes energy to break bonds, and when bonds are formed, energy is released.